Hello students, in this video we're going to be talking about solving systems of inequalities. So we've done systems of equations. Keep in mind inequalities are different because when you graph them, they get shaded one way or another because you want any y value that's bigger or that's smaller, not just the points that are on that line. So let's open it up. Let's look at some reminders and vocabulary and things like that. So a system of inequalities is two or more inequalities that may intersect. So remember, if the lines are parallel, then even if they're shaded, they might be shaded in opposite directions and still not intersect. So keep that in mind. You could still have no solution. It's still possible. The solution to a system of inequalities is the area where they are both shaded, including any solid boundary lines but not dashed ones, and I'll show you what I mean. A point satisfies a system of inequalities if it is in the double shaded area or is on a solid boundary line. And again, I'll show you what I mean by that. So just to kind of compare and contrast, systems of equations we've done, they kind of look like this. You've got two or more lines, maybe a line and a quadratic or whatever, that are intersecting each other, or maybe not intersecting each other, and then you have no solution. But in any case, you're looking for an intersection point. And it's generally 1 point or 2 points or some finite number of points that you're looking for. In this case, notice I've got the same lines here, but since they're inequalities, then I've got infinitely many solutions that could satisfy these constraints. So the solution to a system of inequalities is the area shaded by all or both inequalities. So it's basically like the solution to this one and the solution to that one, wherever they intersect, which is, in this case, in this area. And I don't think that you can see it very well, but this is a solid line. Well, this one, so it's got equal to, this one is a dashed line. And it just didn't print very well. So up here, what I was talking about, something's in the solution if it's on a solid boundary line. That's like right here. All the points on this line are part of the solution. These points are not. And that's all that means. So let's open it up. And to save some time, I've already got these graphed, and we're just going to kind of talk about them. You can use either Desmos or TI Inspire, but just be aware that in the TI Inspire, your equations better be in slope intercept or standard form. Otherwise, you've got to change them. In Desmos, they can be in any form. Okay, so the first one I've graphed this way. So here's my solid one. So anytime I have an equal to, whether it's greater than or equal to or less than or equal to, I'm going to have a solid line. So I'll put that reminder up there for you. Whereas if I don't have the equal to, so if I have either greater than or I have less than, it's going to be a dashed or dotted line, which I've put up here for you as a reminder. So I've got my two inequalities. So this one, this is the dashed one. The solution to this inequality is this whole shaded area, while the solution to this one is this whole shaded area. And notice, if I want the solution to both to that system, I need any area that's shaded by both, and that's this sort of triangular piece up here. And do realize that the shading goes on forever. It's just ran out of room, but the shading does keep going up, okay, even though it's not drawn. So pause that for a second if you need to in order to copy the graph, and then let's look at the next one. So example 2, again, I've drawn it ahead of time to save us some time. I've got my first inequality, which is this one, because it's got greater than, so no equal to bar, so it's a dashed line. And I've got this one, which is a solid line because it's got an equal to, so it's this one. So the solution to the first inequality is this whole shaded area, while the solution to the second inequality is this whole shaded area. And the solution to both, to the system, is whatever was shaded both times, which is this part right here, including that boundary line, but not including that boundary line. Okay, and again, it keeps going forever off the page. Okay, so that would be my solution right there. So any point in that area would satisfy those inequalities. And in fact, we're going to try it with the origin. Does the origin satisfy the system of inequalities above? So basically, I'm testing this point, 0, 0, to see if it's in the solution area. And obviously with the graph, we can see it. It's right there in the double shaded area. We know that. It is in the solution set. But if you didn't have a graph, you could check it algebraically pretty easily. Okay, so the origin is 0, 0, which here's your x, here's your y. And it looks like a little owl. Look at him, isn't he cute? I got my two inequalities, so let me write those down. And so now I want to plug my x and my y into the x and y. So 0 is greater than 2 times 0 minus 3. Let me just finish this one first. So 0 is greater than, so 2 times 0 is 0, minus 3 is negative 3. Is 0 greater than negative 3? You betcha. So that tells us that 0, 0 is in the solution set for the first inequality, which we knew already because we graphed it. But if we hadn't graphed it, then we could tell that way. And so for the second one, 2 times 0 minus 0 is less than or equal to 4. And I'm sorry, that does actually say plus up here. That's the way it was graphed as well. Not that it's going to make a difference in this numerical answer, but just so we know, that is a plus. So if yours didn't print like mine didn't really print very well, please change that to a plus. And the graph is correct. So we're good. All right. I'm back to example 3. So 2 times 0 is 0, plus 0 is still 0. And is 0 less than or equal to 4? Sure is. So since the point worked, the point made both of these statements true, then yes, 0, 0 satisfies this system of inequalities. Okay, so that's basically it. And we'll try some examples in class. Thank you for watching.